So let us enter into next topic, which is what are the attributes and methods of NumPy array. So what can still we can do with the NumPy arrays rather than just creating them. So first we will create a array1 of np dot. We will use arange function arange from 1 to 26. So yeah, so when we print arr1 we will get a array of 1 to 25 numbers between them. So let us know the shape of array1. So we will use array1 dot shape. So this function tells about the shape of the given array. So when we run, so this says that it has 25 elements, that is 25 columns and one row. So this is single row. So it tells only about the columns. So you understand by the shape, dot shape function. It tells the shape about the given array. And think that if you need to convert the shape from 25 comma none to some another shape like 5 into 5, so for that type of uh, things we can do by using array.1 dot reshape. This function helps us to reshape the previous array into a new array. So we need to reshape of the size 5 comma 5. Yeah, done. So it has 5 rows and 5 columns and 5 rows, and you need to take care of that. One particular thing is the multiplication of previous rows and columns should be equal with the multiplication of rows and columns after the reshape. Means here you have 25 and one column, so 25 times 1 is 25, and here when you see the reshape value is given is 5 times 5, so 5 times 5 is 25. The values are equal, so it will have no error and will give a perfect output. Suppose I therefore made a mistake and reshaped it as 3 comma 4. So will it work? Let us see. Yeah, we all know that it got a value error. Cannot reshape array of size 25 into shape 3 comma 4. Why? Because 3 comma 4 uh, is a matrix. So in this matrix we will only get 3 into 4 times, but means 12. We will only get 12 elements, but here we have 25 elements. So there is insufficient of spaces for the input values, we get value error. So please make sure uh, this thing before you are reshaping. And next, suppose let us save this as array 5 and print this array 5 array 5. Yeah, and now if we need the maximum value in a given array, then for that type of use we have to use array5 dot max function. It is a function which returns the maximum value in the given array. So the maximum value in the given array is nothing but the 25. So it has written that value, and same for the minimum value too. So array5 dot minimum. So this is the function which returns the minimum value. Here the minimum value is 1. Yes. So talking about next function. So when working with NumPy or anything else, sometimes you might need the index of the maximum value or the index of the minimum value. Then you might have to write some long code, but we can use array 5 dot arg max. So this returns the index of the maximum value in a given array. So run 25. So we know that the maximum value is 25 and the index of 25 is 24. So the one has the index 0 and the 2 has the index 1 and the 3 has the index 2. So as we continue, therefore, we get the index of 25 as 24. Simple. Then, if you want the index of the minimum value in the given array, we use array.5.arg min 0. So the 0th index, that is 1. 1 is the minimum value and 0 is the index of that minimum value. And if you want to know the data type of your given array, so array.5.dtype. So our data type is int 32. So the data type here are int 32. So these are about the attributes and methods of NumPy array. Let us get into new topic in NumPy, which are familiar with you as you have learned the list in the Python, is how to perform indexing and selection of elements in one-dimensional NumPy array. So let us print array 5. Okay, this is a 5 into 5x matrix, and suppose we will simply work with a one-dimensional matrix. A range, to create one dimension, we use np.arange 1 to 10. So array 6 is 1 to 9. Yeah. So to access any uh, of the element in the array, we know that we have to use square brackets. So array 6 of 3. This 3 means the index of the given element. So index starts with 0 and increases with an increment value of 1. So this 1 has the index 0 and 2 the index is 1 and for 3 the index is 2 and 4 the index is 3 and so on. So I have given the index as 3. So what do you think? What number will print? Is it 2? Is it 3? Is it 4? Or is it 5? Yes, you got it. It is 4. Okay. And to test you out, what does this code will give as output? Time's up. This code will give 2, 3, 4, 5. So this code will run from 1 first index. So index 1 is from here 2 and 5. 5 is up to here. Yeah. So 5 is up to 6. Fifth index is 6. But 5 is not included here. So we will only get up to the value 5. Okay. So the indexes are 1, 2, 3, 4. And here is the same result. And if you want to change the value of those particular series in the array, we can simply give this sort of code. So by accessing the elements in the array and giving the value equal to 10 changes the values in the array. Yeah, so we can see that we have changed the value of 2, 3, 4, 5 to 10 and resulting in 1 comma 10, 10, 10, 10 and 6, 7, 8, 9. So like this we can access and change the values in the NumPy array. And one more question for you. These are all pre-teached in the Python chapter for you. I am just revising you a little bit. So what does this particular code mean? So let us see. Here, this semicolon represents accessing all the values. So we are accessing all the values of array 6 and giving it the value of 25. So when we call out array 6, all the values in the array, irrespective of the index, will get the value 25. So when we print array 6, we will get all the values, all the 9 values as 25. And we also have a particular function from which we can copy a particular array and use it in the further process. It is known as, suppose we are creating array 7, which should be the copy of array 6. So array 6 dot copy. This says that array 7 should have all the values as array 6. So it should copy dot copy. So this runs. Here we can see that array 7 and array 6 have the same values. If I change the values of array 7 to 10, and now we can see the difference between array 7 and array 6. So this is the matter where it all goes from in the regards of dot copy function. This we will use in further projects, and this is one of the prominent functions to be used in the Numpy. So let's dive into topic 5, which is how to perform conditional selection using a Boolean array. So I will explain it in a very simple manner. So let us take an array 8, which I will take it as random int values from 0 to 100, and I need 30 values. If I run array 8, I get these values. So I need to perform a conditional selection, okay, using a Boolean array. A Boolean array is nothing but a array in which the values are limited to only true or false. So in Boolean array, the values should be only true or false. So here, to convert our array 8 into a Boolean array using a condition, so let us call that as Boolean of array 8 is equal to, uh, so array 8 and the value should be more than, suppose, 50. So when we call Boolean array 8, we will get all the values in the form of true or false. So this type of array is known as Boolean array. So when you apply a certain condition to an array and print that array, and it gives input in the form of true or false, it is known as Boolean array. So if you need to get all the true values in this Boolean array or get all the false values in this Boolean array, you have to do simple that array 8, use the slice operator and insert the Boolean array into it. So this gives all the true values. Okay. If not, if you want all the false values, so we can rather do in other way rather than using Boolean array. So reversing the condition which is used right here. So we will keep this as a, yeah. So these are all the true values and these are all the false values. Means when we have used greater than 50, so the greater than 50 all values are true, so these values are all greater than 50, and here less than 50, so all these values are less than 50. So this is how you use a Boolean array using a condition. So the next topic is how to perform operations with array. So operation means mathematical operations with array. So these are of two types. First, operations between array and array, and operations between array and a scalar. A scalar means an integer or a decimal. Okay, so first we will learn about operations between array. So first we will add up some new cells. Okay, so let us take a array A of np dot arrange from 1 to 10 with step up 2, and arrange from 1 to 15 with step up 3. So when we run, A is 13579 and B is 147 10 and 13. Okay, so let us perform some operations between A and B so that you can understand what are the operations meant between array and another array. So when we print A plus B, so the array in each of the uh, same index gets add up. So 1 plus 1 is 2, 3 plus 4 is 7, 5 plus 7 is 12, 7 plus 10 is 17, and 9 plus 13 is 22. And when you subtract between two arrays, the same thing happens with the subtraction too. 1 minus 1 is 0, 3 minus 4 is minus 1, 5 minus 7 is minus 2, 7 minus 10 is minus 3, and 9 minus 13 is minus 4. And as same as A into B, 1 into 1, 3 into 4, 5 into 7, and so on. So you have got a basic idea about operations between array and array. When we come to the part of operations between array and scalar, it works similar as array and array. Just you are replacing B with a new scalar. So when you add 3 to the A, means when you are adding 3 to a numpy array, it gets added up to all the elements. So actually the A array is 1, 3, 5, 7, 9. By adding plus 3, each element gets added by 3 and the array changes to 4, 6, 8, 10, 12. So when you subtract 3, same happens. 1 minus 3 minus 2, 3 minus 3, 0, and so on. And when we do B into 2, we get B is multiplied by 2. So every element in B is multiplied by 2 and B divided by 2. So you are understanding the concept, right? So when you are uh, operating between array and array, the operations take place between the elements with same index. But when your operations are taking between array and scalar, the operations will be taken through each and every element in the array. So there are multiple operators like b double slash 3 and yeah, power function, and so on. So let us discuss topic 7. Here we will discuss about how to perform with NumPy universal functions. So you will get to know about universal functions in just a bit. And we will start with simple mathematical functions. Like first we will print our array A. So 1, 3, 5, 7, 9, and for example B 1, 4, 7, 10, and 13. So our first function is add add B comma A. So this gives the addition of arrays A and B. And next is subtract. Subtract B from A. So subtraction is done. And same with multiply. Multiply. Next, exponential. So for this we have a function called .exp. So this will give the exponential values of all the elements in the array. So e power 1 is 2.718. So we all know that. So and next is e power 4. E power 4 is 5.45 something, and e power 7 is 1.09 into 10 to the power of 3, and e power 10 and e power uh, 13 values are given as respective. And then we are going to use np.sqrt. This function is nothing but giving the square root of each and every element in the given array. So I am giving the array A. So sqrt is nothing but square root. So dot sqrt gives the square root of every value in the given array. Yeah, so here are the square roots. Uh, so in array A, we have the last digit as 9. The square root of 9, we all know that is 3. So hence the 3. And when we come to the trigonometric functions, we have sine. Np.sine gives all the sine values of elements in the B, and np.cos and np.tan. So these are all the trigonometric values, and for cosecant, secant, and cot, we have to do just 1 divided by, then we can get the cosecant value of them too. So here we completed the trigonometric functions. And talking about the logarithmic, to use the logarithmic functions in Numpy, we use np.log of b. So this gives the logarithmic values of all the elements in the b. Yeah. So in the b, the first value is 1. Log of 1 is 0. So hence the 0. Next, so we will talk about some yeah, this is a great function. We will talk about sum of axis is equal to 1. We will talk about this axis later. So axis 1 is not there. Okay. Yeah, axis 1 is not there. So this sum is nothing but the cumulative sum. So I will write a comment that it is cumulative sum of all the elements. Yeah. And next we can get into with a dot mean. So this function gives the mean, average of mean of all values. Yeah. So array A mean value is 5. And so next we have median. For median, we can use np dot median of A. So the median of A is 5. Here we can see that mean and median of A are same. And talking about next function, it is the correlation coefficient. And for that, we can use the function np dot core coef of A. So the correlation coefficient of A is 1. So correlation coefficient. And let's talk about the next function, sort. So a dot sort. When we print a, okay, this sort function is for, yeah, I will make you understand in a bit. Let us suppose a c is an another array of, yeah. So we have declared a variable c in which it has stored an array of 4, 9, 2, 7, 10, 1. It is in jumbled manner. But if we need to make the C in a sorted way, so to sort it out, we use dot sort function for that. So after using dot sort, we can use, we can see that in C, the numbers are arranged in a ascending order from lowest to highest. So this is what the sort functions do. And the next function is transposing array. So this might be a new topic for most of the people, but we will see in the future about what does this transposing of array does. So for transposing array, we can simply use a dot capital T. Yeah, I think so. Transposing of array is not working on a, but we can later see with a new array or new data set in which transposing can be applied. And the last function which we are going to talk about is concatenating. So concatenating is nothing but adding a new array in the last of a single array. So let us add B to the end of A. For that, we need to write a code called np dot concatenate. Concatenate. Yeah, A comma B. And we need to give this in an order pair. Yeah. So 1, 3, 5, 7, 9. These are all the elements of A. 1, 4, 7, 10, 13 are all elements of B. So B is added at the end of A. This is known as concatenation. So by this function, we have completed the Numpy. And rather than these functions, there are many more functions which you can read from the documentation of Numpy. And we will practice NumPy not only in a single class, and we will practice NumPy throughout the machine learning, because there are numerous functions and numerous ways of applications of NumPy. So I will write here, we will practice alongside with the machine learning. So yeah, uh, today's class is up to this, and happy learning.